Welcome back, everyone. Today we're going to be talking about the product rule of derivatives. Now, if you're taking calculus, this is probably like week one stuff. You're told this is the formula. There you go. Be happy with it. You aren't told why. Again, the reason why I'm here is to talk about why. So we get that the derivative of two functions multiplied together, right? A product means the result of multiplying two things. The product of f of x and g of x, if you take the derivative of that, you get f of x times g prime x. Prime just means the derivative of. So f of x times the derivative of g of x plus the derivative of f prime of x times g of x. Now, this looks like it comes out of nowhere, right? Why can't we just say the derivative of f of x times g of x is, f prime times g prime? That'd be a lot easier. Why do we get specifically this? And the reason why actually is very interesting, and it has to do with the difference quotient, which was the subject of last video. Okay, so first of all, we have to get our f of x and g of x into this difference quotient form. So let's do that. Okay, so this is what that looks like. The derivative of f of x times g of x is going to be this whole limit. Again, it's just a difference quotient, except every f of x is an f of x times g of x, right? So what we have here is going to be really wonky to look at. So there's a very nice trick to simplify, and that's going to be adding 0. Now, that sounds stupid. Adding 0 doesn't do anything, dummy. But the trick here is to add 0 in such a clever way that we can refactor and kind of reshape the form of the expression into something more recognizable. We rewrite it in this way. We bring the left side here and the right side here, right? We have this minus f of x g of x, and that's right here. And then the positive f of x plus h g of x plus h comes over here, and they're both over h, so we just split the fraction. Now, in the middle, we have two more fractions that we're going to set up. One's plus and one's minus. So the goal is to have both of these fractions be the exact same thing in such a way that they will cancel to be 0, obviously, but also in a way that we can factor this expression in a new way. So both of them are going to have h in the denominator. And then the trick is that we want this numerator to be f of x plus h times g of x, right? Very similar, but only one of them is plus h, the other one is just of x. And then, of course, we have to do the same thing for this fraction to ensure equality. Okay, so now we're going to carry this limit down, and then we can factor an f of x plus h out from this. Now what we get left with is the g of x plus h here, and then minus, factor out the f of x plus h, we get just g of x here. And then plus, and we're going to do a very similar thing here, where we factor out g of x, and then we get f of x plus h minus f of x over h. Okay, so what we're going to see here is that given the context of the limit as h approaches 0, this is exactly equal to g prime of x. And this is exactly equal to f prime of x. So what we have now is the limit as h approaches 0, bring that down one last time, of f of x plus h times g prime of x plus g of x times f prime of x. Now the very last thing to do is to finally evaluate this limit. Basically just plug in 0 for the h, and look at what we have. Our final result f of x times g prime plus g of x times f prime, which, as we see, is the original thing that we're trying to prove, this product formula, right? The product rule. So it's a very neat trick of adding 0 to an expression to be able to refactor it. So it's nothing incredibly complicated, it just takes some outside the box thinking, but this proves why the product rule holds. Thank you so much for watching.